Let us continue electron gain enthalpy. What is electron gain enthalpy? Electron gain enthalpy in the sense we have to take isolated gaseous atom. That isolated gaseous atom will take an electron. We have to take isolated gaseous atom. This isolated gaseous atom take an electron and becomes anion. While what is the energy involved? What is the energy involved? That is called electron gain enthalpy. Amount of energy involved is called electron gain enthalpy, we can say. So, now we will take an example for this. We will take a chlorine atom in the gaseous state. We are taking chlorine atom in the gaseous state. It takes an electron and becomes Cl minus. We are taking chlorine atom in the gaseous state that takes electron and becomes Cl minus. Chlorine atom in the sense that nucleus contains 17 protons. In that nucleus, 17 protons present. And the electronic configuration, if you see, 1s2, 1s2. Next one is 2s2 to p6, 2s2 to p6. Next one is 3s2 3p5, 3s2 3p5. It is the electronic configuration of what means chlorine atom. Now, incoming electron, it is the incoming electron. This electron comes. When this electron comes near the chlorine atom, what happens means between nucleus and this electron, attraction is possible. Due to attraction, the system chlorine atom liberates energy. Chlorine atom liberates energy. And between these electrons, between this electron cloud and this electron, what is possible means repulsion is possible. Repulsion means system will absorb energy in order to overcome the repulsion. This chlorine absorbs energy from surrounding in order to overcome this repulsion. Then only if repulsion is overcome, then only the electron will add into Cl. So, now net energy change we have to see. Net energy change is called delta EGH, electron gain enthalpy. Net energy change is called electron gain enthalpy. That is how much in the sense minus 348 kilojoule per mole. Minus 348 kilojoule per mole. So here this kilojoule per mole. Here this minus indicates exothermic reaction. Minus indicates exothermic reaction. So in this reaction, in this chlorine atom takes an electron, becomes Cl minus. This is a exothermic process. That means in this process, energy is liberated. Therefore, out of attraction and repulsion, what is dominating factor means attraction is the dominating factor. Out of attraction and repulsion, which is dominating means attraction is dominating. Therefore, net energy change is exothermic, liberation of energy. Liberation of energy, we can say. So this is called a electron gain enthalpy. So next we will see how the electron gain enthalpy changes in a group and changes in a period. That we will see. Now we will take a group. In group, how it will change. That point we will see. Now fluorine will take, it takes electron and gives F minus. Now fluorine takes electron and gives F minus. Okay. Here fluorine nucleus we will see. Fluorine nucleus contains 9 protons. This is 1s2. Electronic configuration will write 1s2. Then 2s2 2p5. 2s2 2p5. So now it is the incoming electron. Between incoming electron and nucleus, between nucleus and incoming electron, attraction is possible. Due to attraction, what happens means energy is liberated. So between this electron cloud and this electron, repulsion is possible. To overcome the repulsion, the system absorbs heat. System absorbs heat. So net energy change will take net energy change. Net energy change is called electron gain enthalpy. Electron gain enthalpy of fluorine is minus 333 kilojoule per mole. minus 333 kilojoule per mole for fluorine. So here this minus indicates this process is exothermic process. Exothermic process means this is a dominant factor. Now we can say this is a dominant factor, we can say. Okay. Now this is what in the sense a dominant factor. Okay. Liberation of energy is a dominant factor. It is exothermic process. This is called electron gain enthalpy. Okay. Next we will take a chlorine atom. We will take chlorine atom takes electron and becomes Cl minus. Okay. Now in this chlorine atom, nucleus contains 17 protons. Electronic configuration, if you see, 1s2, then 2s2 to p6, 2s2 to p6, then 3s2 3p5. Then we can say 3s2 3p5, we can say. Okay. Now it is an incoming electron. Now between this nucleus and this incoming electron, attraction is possible. Between this electron cloud and this electron, repulsion is possible. To overcome the repulsion, system needs energy. For attraction, system liberates energy. System liberates energy. Now we will take net energy change. Now we will take net energy change. The net energy change is called electron gain enthalpy for chlorine. This electron gain enthalpy for chlorine is minus 348 kilojoule per mole. So this is called electron gain enthalpy. Here, electron gain enthalpy of chlorine is negative, that is exothermic. So exothermic in the sense, what is the dominating factor in the sense, energy, liberation of energy is the dominant factor. So attraction is the dominant factor. So in this case, for fluorine, attraction is a dominant factor. For fluorine, attraction is dominant factor. For chlorine also, attraction is a dominant factor. So now here we will see number of shells. We will see in this case number of shells in the sense, here number of shells 2. Here number of shells 2. So the incoming electron is adding into second shell. Here we will see number of shells 3. Number of shells 3. Here incoming electron adding into third shell. Therefore, what happens? Distance, what happens from fluorine to chlorine? What happens to the distance? You see, from fluorine to chlorine, what happens to the distance? Distance increases. Distance increases in the sense. Distance increases in the sense. What should happen to the magnitude of attraction? Attraction should decrease. Attraction is decreases means energy liberated should decrease. Energy liberated should decrease in the sense electron gain enthalpy decreases. Energy liberated, amount of energy liberated is less in the sense electron gain enthalpy is less. But how it is there? How the experimental fact is there? That we'll see. Experimental fact says that here 333 kilojoule of energy is liberated for fluorine. For chlorine, 348 kilojoule of energy is liberated. So the explanation is against the experimental fact. The explanation is against the experimental fact. Sir, let it be. We will see about this later. Now we will go for another thing. Now we will take chlorine. We will take chlorine atom. Then we will take a bromine atom. We will take bromine atom. For chlorine, electronic configuration is what means neon 3s2 3p5. For bromine, electronic configuration is argon 4s2 4p5. So 4s2 in the sense in between that 3d10 will come. Here 3d10 comes. 3d10 4s2 4p5. This is bromine. Now both are taking one electron and becoming anion. This is becoming Cl minus. This chlorine is gas. Here also taking electron and becoming Br minus. Both are taking electron and becoming respective anion. So, now here nucleus will be there. Between this nucleus and this electron, attraction is possible. Between this electron cloud and this electron, repulsion is possible. In the same manner, here nucleus will be there. Between this nucleus and incoming electron, attraction is possible. Between this electron cloud and this electron, repulsion is possible. Sir. Now we will see here electron gain enthalpy. Will see here electron gain enthalpy is how much in the sense minus 348 kilojoule per mole. Minus 348 kilojoule per mole. Here electron gain enthalpy will see minus 324 kilojoule per mole. Minus 324 kilojoule per mole. So here negative sign means energy is liberated. That means exothermic in the sense dominant factor is what means this attraction. This attraction is the dominant factor. So here electron gain for bromine, electron gain enthalpy is minus 324. Minus in the sense exothermic reaction. That means net energy change is energy liberated. Energy liberated in the sense attraction is the dominant factor. In both cases, what is the dominant factor means attraction. So in both cases, attraction is the dominant factor. Here we will see in both cases we said attraction is the dominant factor. Now we will take here number of shells in chlorine. Chlorine number of shells we will see. In chlorine number of shells if we see 3. That means this incoming electron is going to third shell. In bromine we will see. In bromine number of shells we will see. In bromine number of shells is 4. That means this incoming electron goes to fourth shell. This incoming electron goes to fourth shell we said. Now we will take down the group. Down the group means this is halogen family. In the halogen family how it is there means chlorine, below chlorine bromine, then below bromine iodine will be there like this. Down the group we will see. Down the group what happens to the number of shells we will see. Number of shells increases. So chlorine 3 shells, bromine 4 shells. Number of shells increases. Then number of shells increases in the sense distance between center of nucleus and incoming electron. And incoming electron what happens means increases. Therefore attraction between nucleus and incoming electron decreases. Therefore amount of energy liberated decreases. Therefore electron gain enthalpy decreases. So down the group electron gain enthalpy decreases because number of shells increases. Otherwise we can say simply size increases. We can say size increases. Okay, let us see example for this one. Now we will take 7th A group. 7th A group we are taking. In 7th A group it is called halogen family. 7th A group is called halogens. So we will take fluorine. For fluorine electron gain enthalpy is minus 333 kilojoule per mole. Then chlorine will take chlorine minus 348 kilojoule per mole. Then bromine will take minus 324. Then iodine is minus 295. Then astatine is minus 270. Astatine is minus 270. What is the point we have discussed here? Down the group, electron gain enthalpy decreases. Electron gain enthalpy decreases because size increases. This is the fact we said. Now we have taken example here. Now we will see chlorine. Chlorine 348, bromine 324, iodine 295, astatine 270. So decreases. Here what is the exception in the sense? Exception is fluorine and chlorine. Fluorine and chlorine is exception, but from Cl, from chlorine onwards, it is following the periodic trend. From chlorine to astatine, periodic trend is followed. From fluorine to chlorine, periodic trend is not followed. Now we will take a 6th A group. 6th A group we will take. 6th A group is called chalcogens. 6th A group is called chalcogens. Chalcogens means oxygen. Oxygen, the electron gain enthalpy is minus 142 kilojoule per mole. Then sulfur. Sulfur is minus 200 kilojoule per mole. Then selenium. Selenium is minus 195. Tellurium. Tellurium is minus 190. Polonium minus 170. Minus 170. Now in this case, how electron gain enthalpy changes in the sense sulfur to selenium. Oh, correct. Selenium to tellurium. Tellurium to polonium. How it is there means periodic trend is followed. Periodic trend is followed here. Periodic trend is followed means what? Electron gain enthalpy magnitude decreases down the group. What is exception? Oxygen to sulfur is exception. Oxygen to sulfur is exception in this 6th group. 6th group we can say. Sir, so what is the conclusion in the sense? Down the group, as size increases, therefore electron gain enthalpy decreases. It is a conclusion. In that case, some exception is there. What is the exception in the sense? Here, fluorine to chlorine is there, exception is there, and in 6th family, oxygen to sulfur, exception is there. Similarly, now we will see 5th group. In 5th group is called Nicogens. 5th group is called Nicogens. Nitrogen, if you see, minus 31. Sir, this group we will see later because some variation is coming here. Sir, we will see in this case. So, in the 7th group, fluorine to chlorine, abnormal behavior. In 6th group, oxygen to sulfur, abnormal behavior. What is the reason? That we will see. Now, fluorine we have taken. Fluorine for this electron gain enthalpy we said. Chlorine we have taken. For this we said electron gain enthalpy. Okay. Now, how the electron gain enthalpy is there means it is showing abnormal behavior. So, this abnormal behavior we cannot explain using this general term, using this general thing. We cannot explain. This is experimental fact. Experimental fact we have to explain using suitable explanation. That's all. So here for fluorine 333, chlorine 348. So for which electron gain enthalpy psi means for Cl. For fluorine F it is less. So we can't take this explanation. We can't give this explanation. We can't give such. That means what explanation we can give in the sense here. In this case, energy liberated is less. Here, energy liberated is more. That means this incoming electron goes to explain this. That means here energy liberated is less. Energy liberated is more. To explain this, we can't give this statement. This statement we can't give. Okay, we can't give this statement. So this statement we cannot give. This statement we cannot give. This explanation we cannot give. Sir. So what is the explanation we have to give? That we will see. What is the suitable explanation? That we will see. Now, incoming electron goes to 2s to 2p5 second shell. Here incoming electron goes to 3s to 3p5 third shell. This second shell is more compact when compared to third shell. Second shell is more compact when compared to third shell. This point we can take. Okay, so second shell is more compact than third shell. Second shell is more compact than third shell. Compact in the sense what? Density of electron cloud is more. That is the meaning. So density of electron cloud of second shell is greater than that of third shell. Density of electron cloud of second shell is greater than that of third shell. That is the meaning. Therefore, this incoming electron gets higher magnitude of repulsion with the second shell when compared to this incoming electron. So what happens means incoming electron. Okay, so 1 minute, this we will rub it. Now, incoming electron gets higher magnitude of repulsion, with the second shell in fluorine than that of in chlorine. Okay, so what we are saying means second shell is more compact than third shell. In this fluorine the valence shell is more compact. In this chlorine the valence shell is less compact. Due to that, density of electron cloud of second shell is greater than that of third shell. This fluorine second shell, valence shell is having higher density of electron cloud. Chlorine valence shell is having lesser density of electron cloud because third shell. So that this incoming electron gets a higher magnitude of repulsion from fluorine of second shell, whereas incoming electron of chlorine gets a lesser repulsion from third shell. Therefore, what happens? Amount of energy liberated in fluorine is less than that of chlorine. Energy liberated in fluorine is less than that of chlorine. That's why electron gain enthalpy of fluorine is 333 kilojoule per mole, whereas chlorine Cl 348 kilojoule per mole. So for which electron gain enthalpy is high means for Cl. Therefore, electron gain enthalpy for Cl is greater than that of fluorine. Okay, therefore we have to give like this explanation we have to give for this one. Okay, sir. Now we will take this 6A group chalcogens. In 6A group chalcogens, oxygen sulfur shows abnormal behavior. We have to give explanation for oxygen sulfur, same like fluorine and chlorine. Therefore, here, what is the conclusion in the sense in this 7th group halogens? Down the group, what happens to the electron gain enthalpy in the sense decreases? That is, that periodic trend is followed from chlorine to astatine. But fluorine to chlorine Cl exception is coming. That exception we have to explain separately with respect to repulsion. Sir. Then 6A group chalcogens. In chalcogens, electron gain enthalpy down the group decreases with that periodic trend is followed from sulfur to polonium. Exception is oxygen to sulfur. This oxygen to sulfur exceptional case that is explained as same like fluorine and chlorine. So now we said electron gain enthalpy we said. Okay. So electron gain enthalpy, how it varies in a group, and what is the exception? What is the exception that we said? So next we will take what is the example in the sense nitrogen we will take. Nitrogen electronic gain enthalpy, we will see nitrogen takes electron and gives N minus. For this, what is the electron gain enthalpy in the sense plus 31 kilojoule per mole. Now see, generally electron gain enthalpy in the sense exothermic, negative. Generally, if you see, what is the electron gain enthalpy? In general, electron gain enthalpy is negative. That is exothermic. But in chlorine case, see how it is there. In chlorine case, in nitrogen case, how it is there? See, isolated gaseous nitrogen atom we have taken, it takes electron and becomes N minus. Here electron gain enthalpy is equal to plus 31 kilojoule per mole. Sir, why is it so? That we will see. Nitrogen nucleus contains 7 protons. Its electronic configuration is 1s2, then 2s2, 2p3. 2s2, 2p3. Okay. Now incoming electron will take between incoming electron and the nucleus. Between nucleus and incoming electron attraction is possible. Between this electron cloud and this electron repulsion is possible. What is dominating factor such that electron gain enthalpy is endothermic? So we can say repulsion is the dominant factor. Repulsion is the dominant factor. Therefore, electron gain enthalpy is endothermic. Set. Why repulsion is the dominant factor? Why not attraction? Generally, electron gain enthalpy is negative, that is exothermic. Generally, attraction is the dominant factor. But in the case of nitrogen, why repulsion is a dominant factor? That we'll see. Okay, nitrogen electronic configuration, if you see 1s2, 2s2, 2p3. 2p3 in the sense off-filled configuration. 2-filled is off-filled configuration. But here what is the configuration? 1s2, 2s2, 2p4. 2p4 in the sense partially filled configuration. 2p4 is partially filled configuration. So nitrogen is off-filled stable configuration, that is converting into partially filled configuration. Therefore, electron gain enthalpy is showing abnormal behavior when compared to normal, so that it is endothermic. Set. So remember that nitrogen electron gain enthalpy is endothermic. Okay, nitrogen electron gain enthalpy is what means endothermic, you can say. Sir, in this category, like this category, which elements are coming in that category, like this category, that we will see. In which case and all, electron gain enthalpy comes as endothermic, that we will see. Generally, if we see exothermic, endothermic also possible in exceptional cases. What is that exceptional cases we will take? Now beryllium we will take. Beryllium takes electron and becomes Be minus. In this case, electron gain enthalpy is equal to how much in the sense? Plus 66 kilojoule per mole. Why? Because it is 1s2, 2s2. Now it is 1s2, 2s2, 2p1. Electron goes to 2p. 2p is having less penetration power. 2p is having less penetration power. Therefore, only here electron gain enthalpy is endothermic. Here 2s2 is s orbital is having higher penetration power. 2s is completely filled, but 2p is partially filled and also less penetration power. So electron gain enthalpy is positive for this. Next, magnesium we will take. Magnesium coming under the group of beryllium. So here if you see Mg minus we will take. Here Mg minus, here electron gain enthalpy is how much in the sense plus 67 kilojoule per mole. Same like beryllium. Beryllium and magnesium coming under same group. So for beryllium, what explanation we have given, same thing we can follow for this magnesium. Next we will take noble gases. Next we are taking a noble gases we will take for helium. For helium configuration is 1s1, 1s2. For helium configuration is 1s2. For this electron gain enthalpy is how much in the sense plus 48. Because it is stable configuration. Helium is having stable configuration. If you give electron, stable configuration is disturbed. That's why electron gain enthalpy is endothermic for this. Now neon we will take. Neon is plus 116. Next argon. Argon is plus 96. Next krypton will see. Krypton is plus 96. Then xenon we will take. Xenon is plus 77. Then radon we are taking plus 68. So all these are endothermic. So that generally if you see exothermic and exceptional cases, many exceptional cases are there in regarding electron gain enthalpy. That is what in the sense in the down the group we said exceptional case. Down the group we said exceptional case. In halogen family, F and Cl comes as exception. In the oxygen family, oxygen and sulfur comes as exception down the group. Another thing, another point is what? Generally electron gain enthalpy is negative, but these elements are showing positive. Nitrogen shows positive, beryllium, magnesium shows positive, and noble gases shows positive. Like this is the set. Now we will see how the electron gain enthalpy varies in a period, that we will see. Now we will take second period, we will take. In second period, left to right we will take. Left to right. Now we will take lithium. Lithium minus 57 electron gain enthalpy. Beryllium is 66. Boron minus 15, minus 15. Carbon minus 121. Nitrogen plus 31. Nitrogen plus 31. Oxygen minus 142. Oxygen minus 142. Fluorine minus 333. Then neon plus 116. Plus 116. This is a second period left to right we have given. In this one, which and all shows positive? See beryllium, nitrogen, neon. Sir, this we will take it as exceptional. Sir, exceptional we will round off. So exceptional cases we have rounded off. Remaining we will take. Remaining cases how it is there, that we will see. Here minus 57. Here minus 15. Here variation is there. Lithium to boron, if you see, variation is there. So from boron we'll see. Boron to carbon, what happens you see? Boron to carbon, what happens means electron gain enthalpy increases, rising. From carbon to oxygen, rising. From oxygen to fluorine, rising. So in this boron, carbon, oxygen, fluorine, if you see, if you go like this, what happens means electron gain enthalpy increases and it is exothermic. Magnitude increases and exothermic. So why is it so? We will see. Now along the period, effective nuclear charge increases. Therefore, attraction with the incoming electron, increases. Attraction with incoming electron increases. Therefore, electron gain enthalpy increases. Okay, electron gain enthalpy increases. So along the period, effective nuclear charge increases, but number of shells how it is there means remains same. Number of shells if you see remains same along the period. Okay, so here effective nuclear charge increases. So attraction with incoming electron increases. Therefore, electron gain enthalpy increases. Like this we can say. Therefore, in the along the period, how the electron gain enthalpy is there means in this way it is there. So in this along the period itself, how many exception cases are there? It is also actually the second period contains 8 elements, but we have considered how many? Only 4 elements we have considered, because remaining and all exceptional cases. So like this is there. So if the question is asked superficially, how electron gain enthalpy varies in a period? Superficially, if it is asked means we have to say increases. That's all. So particularly mentioning lithium to beryllium or lithium to boron or carbon to nitrogen, like this particularly mentioned in the sense, then we cannot give this general explanation. This general concept we cannot give. Okay, sir. Now this is a general concept by taking boron, carbon and oxygen and fluorine. Sir. So in the period how electron gain enthalpy varies, that point we have seen. Sir. Next we'll go for next point. Now isolated gaseous oxygen atom it takes one electron and becomes O minus. This is called a first electron gain enthalpy. It is called first electron gain enthalpy. This is equal to how much in the sense minus 142 kilojoule per mole. Okay, so it is a minus means exothermic. Exothermic means here what is the dominant factor means attraction is the dominant factor between oxygen nucleus and incoming electron. Set. Next, this O minus takes an electron and becomes O2 minus. For this is called second electron gain enthalpy. It is called second electron gain enthalpy. So second electron gain enthalpy means O minus taking one electron and becoming O2 minus. This process is called second electron gain enthalpy. Second electron gain enthalpy is plus 702 kilojoule per mole. Plus 702 kilojoule per mole. This plus indicates endothermic. Endothermic means here what is the dominant factor means repulsion is the dominant factor. Repulsion is the dominant factor. So between this electron cloud and this incoming electron, repulsion is the dominant factor when compared to attraction. So remember that exothermic means attraction is the dominant factor between nucleus and incoming electron. Endothermic means repulsion is the dominant factor between this electron cloud and incoming electron. Okay, this is the concept. So at exothermic means say that attraction is a dominant factor between this nucleus and this incoming electron. Endothermic in the sense say that repulsion is a dominant factor between this electron cloud and incoming electron. That's all. Okay, set. So here we have seen first electron gain enthalpy and second electron gain enthalpy we have seen. Now we will take another example for first and second electron gain enthalpies. Now we will take sulfur gas plus electron gives S minus this is called a first electron gain enthalpy. This is equal to how much in the sense minus 200 kilojoule per mole. So here minus in the sense exothermic in the sense attraction is the dominant factor. Okay, next S minus takes an electron and becomes S2 minus. This is called a second electron gain enthalpy. For this, what is the value in the sense plus 332 kilojoule per mole. Plus means endothermic. Therefore, what is the dominant factor means repulsion is the dominant factor in this case. So first electron gain enthalpy, second electron gain enthalpy means what we came to know it. Next point we'll see. We'll take what is the relation between ionization energy and the electron gain enthalpy. That relation we'll see. What is the relation between ionization energy and the electron gain enthalpy? Okay. Now we'll take sodium in gaseous state. Sodium in gaseous state we have taken. It takes electron and becomes what means Na minus. It is called what means electron gain enthalpy we can say. This is called electron gain enthalpy. Okay. If sodium atom in gaseous state donates one electron and becomes Na plus gas. Like this we'll take. Sodium is becoming Na plus. That means from sodium we are removing one electron. Therefore, isolated gaseous sodium atom becoming Na plus. This is called energy involved in this process is called ionization energy of sodium isolated gaseous sodium. This process is called energy involved in this process is called ionization energy of isolated gaseous sodium. Okay, so isolated gaseous sodium we have taken. To this we are supplying energy, we are removing electron and it becomes Na plus. The energy involved in this one is called ionization energy of isolated gaseous sodium. Okay, next we will take Na plus gas. We will take, it takes one electron and becomes sodium. Okay, this is called what in the sense electron gain enthalpy of Na plus gas. Okay, now see Na plus gas, Na plus takes an electron and becomes Na. So taking an electron means gaining an electron means electron gain enthalpy. Electron gain enthalpy of which? Na plus. Electron gain enthalpy of Na plus. Okay, now we will see this step, we will see, and this step we will see. Now you see these two steps, how these two steps are there, just reverse. So now you say ionization energy of sodium and electron gain enthalpy of Na plus. What is the relation between these two? Okay, now this step you see, and you see this step. Are they reverse with each other? Inverted? Then you say the relation between these two, ionization energy of this gaseous sodium, electron gain enthalpy of this Na plus gas. What is the relation between these two? They are equal in magnitude but opposite in sign. That's all. So ionization energy is equal to opposite of electron gain enthalpy. Okay, ionization energy means what? Knocking out electron. Electron gain enthalpy what? Taking electron. This is meaning is taking electron. This meaning is removing electron. Therefore, how the magnitudes will be there? Magnitudes will be equal, but sign is opposite. Because these two steps are exactly reverse with each other. So, next, electron gain enthalpy. It is called what means electron gain enthalpy and electron affinity. This is called what means electron affinity. Now, electron gain enthalpy is a negative means exothermic. That means attraction is the dominant factor. Electron affinity is what means positive. That means a positive tendency to take electron. Positive tendency to